Hello everybody, my name is Elliot and I'm from a company called Hyperexponential. My talk today is on static callbacks in React hooks, but just a quick note on Hyperexponential. We're a small insurtech, fintech startup, usually working in South London, but a bit all over the place at the moment. We deal with some really interesting problems using some really interesting data sets that most people don't kind of realize exist. And we have a lot of talented people internally who are always looking for more. So there'll be an email at the end that you can send a message off to if you're interested to join us. But my talk today is on static callbacks and React hooks, and specifically what I think class components did right. And I should probably preface this by saying a few things about class components and functional components. So I really don't like class components. I think there's too much boilerplate. They can be really difficult to read when they get large, and they're very tricky to split up and abstract. You can't really share functionality very easily. In comparison, I really like functional components with hooks. There's less syntax and boilerplate, or at least it's a lot more understandable when there is. It's really easy to split up and abstract with custom hooks, and you can make large components really easy to read that way by just splitting up certain functionality and sharing it or putting it in different files and turning your really long components into a really short and easy to read small ones. And of course, there are many, many more, the effect system, etc., etc. I won't go onto it right now. But there's one thing I really don't like about functional components with hooks, and that's the useCallback hook. And I think actually it's quite a lot worse than a class method. And the main reason for this is something called reference equality. And if you've seen any of my prior talks, you'll know that I tend to bang on about reference equality a little bit and optimization. But to me, it's really important. And for building really big and complex optimized apps like we do internally at Hyperexponential, it does become very important. So when you have a class method, the reference is constant for the life of the class. And it can always access the most up-to-date props and state. If it uses a prop or a state, it just uses the most current version of it. There's no chance of it going stale. Whereas a useCallback hook, well, its reference changes every time a dependency changes. And if you want to use props or state inside the hook, you need to add it to the dependencies to validate rules of hooks, and so that it doesn't use a stale version of it. But that means the reference is going to update every time that dependency changes, which means there are going to be more updates the more dependencies that you have, and this starts to get really out of control. But before I dive too far into that, I'm just going to talk about what I mean by reference equality, because some people might not be super familiar with it. So, quick sidebar. Booleans, strings, numbers, null, undefined, all primitive value types in JavaScript and TypeScript are all compared with value equality, which means that you say, is true equal to true? Is string A equal to string B? Whereas objects and functions are slightly different. They're compared using references, which doesn't necessarily mean are they the same thing? Do they equal the same thing internally? It's about, are they the actual same instance? Is it the same object? Object A and object B might have the exact same contents, but they might not be referentially equal if they weren't actually the same object. And functions are very similar to this. They also are done by reference equality, but it's a lot more difficult to check whether the contents are the same in a function. You can write a deep equality check for objects, and that will check value equality. The horrible and don't do this way of doing it is JSON stringify. That takes a very long time, but for you can write some pretty optimal equality checks. Just the worst case time is when they are the same, because you have to check literally every key value property pair. You can't really do the same with functions. It's really quite a bad idea and very difficult, because you essentially need to write a test suite that you're going to run every time you get a reference update to say, does this function do the same thing as its past version? And actually, if the function's side effecting, you can't run that safely without causing some code to affect that maybe you didn't want to execute that function if it was the same, so it just wouldn't work. And it's generally quite a bad idea. So that said, why does reference equality matter in the terms of React components? Well, if you've got a component that re-renders, and it can and often should trigger re-renders of its children. But sometimes you might not want it to. Sometimes its children haven't actually updated at all or don't need to update, and they should just be left as is. And we can cut the tree there and stop the updates propagating down. And in class components, there was an internal method called should_component_update. And we could just write things as pure components, which would basically instantiate a should_component_update method with a shallow equality check. But we could do a memo around a functional component as well, if we really wanted to. And this is actually really great. And a lot of the time really helps with a lot of optimization problems, because it does that shallow reference equality check. It says, okay, is this string equal to this string? Is this object the same as this object? It's slightly less useful for identical objects or functions with different references. It means that you have to memorize your object higher up in the tree. But for functions, especially functions without static references, it's basically useless. It doesn't do that optimistic update step, and it can really screw up all your fancy optimization work. So let's take a look at an example. Here we have a dialog manager class. This is just a class that's going to wrap around some custom dialog component that we want to share about. It's pretty dumb and just needs all of its external information passed in. But we might share the internal dialog around that you can see in the render method, but we're going to control its state from outside. And that general dialog component might take an open state, it might take a warning state, it might take a title, and it, in this case, takes an onSubmit callback. So perhaps there's a button inside where when you click it, it fires that onSubmit, or maybe when you hit enter on a text field inside, that would fire the submit method. So our manager needs to provide that to it. Now this manager in this case has a prop called update server that maybe it needs to send some data to, and it has some state. It has the open state, the warning, and maybe an internal value that it's going to use for some stuff. We initialize all that in the constructor, and then we have functionality to control the open and close and warning states and any other functionality within the constructor within this class. And we're going to ignore that for now. What we really care about is the submit that we pass down. So we've got this onDialog submit method, and this uses that props.update server and uses state.value. And so it always wants to use the most up-to-date version of those props and state to fire. And when the method is instantiated at the construction of the class, its reference is created and then just left. It is static for the lifetime of the component, which means that the dialog doesn't receive a different onSubmit prop ever. It gets it once and it is static. And that's great. So now that dialog is just only going to update if state.open, state.warning, or the title changes. Let's take a look at that as a functional component. Well, here we have it as a functional component with hooks, and it's broadly the same. It still takes the update server prop. We're using the same internal state, it's just set in a more split out, hooksy kind of way. We could do this with a single use state with an object pattern, but here it's more clear, I think, and we're not really using it anyway. We map across the same functionality to control open, close, and warning states, but where the crucial difference lies is in the callback. So we have this onDialog submit that now is a useCallback that calls update server with value. Well, now we have to put that update server prop and the value piece of state into the dependency array. Otherwise, we'd be using stale versions of it, and the callback wouldn't be particularly useful at all. But this means that that onDialog submit will update whenever update server or value changes. With value, this could be changed very frequently whenever a keystroke is pressed. And update server, if it's not a referentially stable callback coming in from above, then that could be updating really frequently and propagating an update down the tree that we don't want. So we've got a problem here that maybe that dialog might change and it might re-render when it hasn't actually had anything that it needs to change for, only on submit that previously was pretty static. So React is built along this principle that your view should be a function of your data. And I also like to think of the fact that really a component should only re-render if it has new information to show to the user. You're talking about conveying information to the user with a view. So given that, why would this update? Why should this update? Well, the dialog should update if the open state changes, or if it gets a different warning state. Maybe it needs to change its background color to red, or it needs to put a little warning message on. Or maybe if the title changed, here it's static, but maybe that title could be dynamic, and we want that to change. But probably it doesn't need to update when the onSubmit changes. But in this case, it will, whenever that update server or that value changes. And this is annoying because we had this behavior before with the class component, but now we've lost it. And now we're getting more updates than are necessary. So it sounds like what we want is callbacks with static references that always use the most up-to-date functionality. Well, okay, great. Well, will this actually work? Because our use callbacks are kind of dependent at the moment on having dynamic references. Well, let's take a look. Why do we need callbacks? Broadly, there are 3 reasons, I think, that we're going to write a callback function. The first is when we pass a callback to a child component. We might also use one as a way of sharing functionality between multiple other callbacks that we pass to child components. So if we've got multiple things that we're sending in, we might just not want to reuse and rewrite all that functionality and just put it into a single spot that we can share about. And we might rather use callback for that so as we don't break our dependency circles. And as a way of sharing functionality between several useEffect hooks, maybe we've got the same situation with many useEffect hooks and we want to have the same actual function happening. Okay, let's go through these one by one and see if they would work with a static callback. Passing callback to child components. There's no real way of inspecting what a function does from its reference. So if you get passed a function as a component, you don't really know what it does aside from its name. And yes, at runtime you can pick its name out if it's got one defined, but that's kind of it. And since you don't really get any information about it at runtime, when it changes, you also really can't get any information about it, aside from the fact that maybe its functionality changed, but it might not have done. Actually, it might still do the exact same thing, but still had a reference update. You don't know. So if you want to convey anything meaningful to the user about what a function does, or what a button is going to do when it is clicked, you kind of need to pass other props. You need to pass some text for that button. You need to pass a color for that button. If the button goes from a submit to a cancel, its function will change, but you don't know that from looking at the function. You have to pass a text prop that says submit or cancel. You have to pass a color that says green or red. And so if you can say, okay, well then maybe we don't care about that reference changing. The proof for the second case for the shared functionality callbacks is really an induction proof upon this. You just have to say, if I don't care about a reference changing for a callback that I'm passing to a child, then that callback can be static, which means any function that it uses can have a static reference, as long as it uses the most up-to-date functionality. So those two are really easy. Effects are slightly more difficult. Here we have some code that has a callback, so some shared functionality that we're going to use in an effect. And the callback uses some callback dependencies, which because we're good and we obey laws of hooks, we have put into the dependency array. We then have an effect, and that effect says, right, if some check, call the callback. And following the rules of hooks, we should be putting some check and callback into our dependency array. That's fine. And in this case, what will happen is that effect will fire whenever some check changes or any one of the callback dependencies, because any one of the callback dependencies changes updates that callback reference, which then will update the dependency array of the effect. And that's good. Sometimes we want that. The annoying thing is, though, sometimes you don't. Sometimes you actually just want that effect to fire whenever some check changes, and you just want it to call the most up-to-date functionality, but you kind of can't because your callback is now firing too frequently. So you might need to use refs or hack around it, and it gets really annoying. So sometimes that's actually not the functionality you want. But assuming that is, and assuming we have to preserve this functionality with static callbacks, how can we do it? Well, let's assume we have the same code, but with a static callback. So our use static callback here does exactly the same thing as the use callback before, except it doesn't need a dependency range because its reference never changes. It's always just going to call the most up-to-date version of itself, but it's going to have a static reference. To get the same effect with the use effect, all we need to do is just take the callback dependency that we had the callback dependencies that we had before and spread them into our dependency array. Then that effect will fire whenever some check changes or callback dependencies change. So great. That's really useful. But what's even more useful is now we could actually take out callback dependencies and we wouldn't be breaking rules of hooks. Yes, we'd need to put the callback reference in there, but since that's static, we know that it's not going to change and affect the use effect and actually update it more than it needs to. So it's fine. It's just a stale piece that needs to go in there to satisfy your linter. But that means that we can actually have a use effect that only watches the check and then just calls the most up-to-date functionality using any dependency it wants without actually breaking any rules of hooks. So this is great. So it seems like we don't actually need dynamic callbacks, and they only really make things worse. So how do I write a static callback? Well, there are a few ways. You could use refs for things that you use inside the callback. Say you have some props or some state. You could create a ref with an object in it and assign the props and state into it every time the render runs, and then go into your use callback and just pick it out of the ref. And that would work, and that's a good workaround. The problem is that every time that you want to make a callback static as opposed to dynamic, you'd have to do that. And that's a lot of code, and it's a lot of boilerplate to keep rewriting. What we'd really like is something like in that prior example where we just had use static callback and it just worked. Well, yes, we can do that because one of the wonders of hooks is writing custom hooks. So let's write a custom hook. And because it's 2020, let's do it in TypeScript. So here is one. Here's use static callback. And this is going to do some nice things like infer the result type based on the type of the function that you pass in. But crucially, what it does is it takes the callback that you pass in each time that it runs, so on each render, and it stores it in a ref. And then what it returns is a use callback with an empty dependency array. That's why we want to be looking for empty dependency arrays, because empty dependency arrays mean that the function won't update. It means that it will have a static reference. And inside that callback, we call the current of the ref and pass it the arguments through. And what this means is we get a static reference to a callback that always updates with the most current functionality. And that's great. That's exactly what we want. Now, all this being said, this won't fix every problem that you have. And truthfully, this is an optimization. And a lot of times, you don't need an optimization. They're not inherently right or wrong. It's really how you use them. And premature optimizations are the death of any good code base. So make sure that this is a problem that you're finding. Make sure that this is something where you find a update that is being spiked down from some callback that needs to get passed heavily through the tree. And then take it out. But don't try and fix a problem you don't have. And secondly, writing software is complicated. There will be edge cases where static callbacks don't work for you. I'm of the opinion that many of those can be solved in other ways, and actually static callbacks would be really great here. But that's a debate that we can have in the question session or in the comments below. So if you have a question, please do share it. And there is a supporting blog for this article that you can find at medium.com/hyperexponential. But thank you very much. I've got the blog link there. And also, as I said at the top of this talk, we are hiring. So please get in touch at hello@hyperexponential.com. Thank you very much.